What's up, everybody? Welcome back to another video from the Scalar Learning channel. And guys, I can't even believe it. We are already up to week 6 of 7, which means the SAT is next week, guys, next Saturday. Hold on, let me just make sure I'm seeing everything in the chat. Somebody says, hey, what's up, Pierre? Do you have the previous video saved somewhere? Absolutely. So if you're looking for the previous videos, let me show you where to go. If you have not signed up yet for our school platform, here's how you get there. I'm going to post this in the chat. What's up, Cole? What's up, Matthias? You post it in here, or you click in here, sorry, you register, and then once you're on this board, right, go to Classroom, and then you can see all the video replays. Here are all the verbal replays. Here are all the math replays, so you can see all the lectures. And then for the slides and things like that we've gone through, you can click into these. I think for the math ones, maybe not the verbal ones yet, I'm not sure, but the slides should be in there as well if you want those. So make sure to check that out. All right, guys. At this point, okay, if you've been following along with the curriculum and kind of doing everything you need to do, you have taken practice tests 1 through 5. Now that is extremely essential and crucial for preparation purposes and for making sure you are ready to go next Saturday, because practice and repetition, once you have the foundations, once you have the critical concepts down, is absolutely essential. You got to do it, and you got to keep doing it regularly and continuously to stay up to date with everything that can be thrown at you on the SAT. All right. Now, today, what we have on the calendar is we are going through a bunch of practice problems. I'm going to be solving them and going through them and explaining them as well. I'll also be pausing at certain points to answer questions, give you guys a chance to answer these questions as well. But I'm going to go through each one, and there are 37 subcategories we identified, of course, in the everything you need to know about the digital SAT. So we're going to be doing one question per question type. So I've kind of broken them down. These are all questions coming from official College Board tests, whether it's practice tests 1 through 6 or the 2 PSATs that are listed, PSAT 1 and 2. So these are all official questions, and these are all going to illustrate a little something different based on their question type. Cole says, in June, I got a 1300 with no studying. This summer, I've been studying with your help. And Dan says, I got a 1450. Wow, 150% increase. Good job, Cole. That's fantastic. But we can go higher. So keep working, because you can still make some gains in this last week. All right, guys. So and Cole said, I'm very excited for the next week where we can submit hard questions. Yeah. And I'm going to start opening that up actually this week, where you guys can start submitting them, and I'll start compiling them. And then we're going to be able to answer all your questions, or hopefully as many of them as possible, next Tuesday for our final class. Today is our penultimate class, next to second to last class. All right. Here we go, guys. And I got a ton of videos coming out next week as well. Okay. Hold on one second. Let me just get this up so I can make sure to see the chat. 1500 in August. Let's go. All right. So we have subcategory number 1, solving linear equations and inequalities. So this is a nice linear equation, single variable. Now, we have a couple ways we can do this. If you notice, first of all, we could just solve for x, right? And then all of these involve 4x. So we could be like, all right, what's 4 times the value of x, and go that way. Or you could be a little bit slicker here and be like, wait a minute, we have 4x in the equation. I'm just going to minus 6 from both sides, right? And I have 4x is equal to 12, which gives me C for the answer. Can you do this in Desmos? Absolutely. Is that the best way to do it? Absolutely not. It's not the most efficient. But if you can't think of anything else, you can plug this into Desmos, get your value for x, and then multiply it by 4 to get the appropriate equation. All right. Moving on, next category, linear equation word problems. This is question 24. I can't remember from what test, but this is a linear equation word problem. So we know this is 3 values of x and corresponding values of y. K is the result of translating this one 5 units down. What is the x-intercept the line k? So this is a pretty difficult problem for a linear equation word problem. So the first thing I want to do is I want to get my equation for line h, right? So how do I start? I need to calculate the slope. What's my slope? Rise over run. Let me make this a little thinner. So we're going to take the difference of the y values, any 2 y's, but I'll do the top 2. So that is, let's go the bottom minus the top. So 160 minus 130 is 30. And then 23 minus 18, we also have to go bottom to top there as well. That's 5. So we know we have a slope of 6. So my current equation is y equals 6x plus some y-intercept. That's what we have to figure out. Now, I can do a little mental math here to figure out my y-intercept, or you can kind of plug and chug using a calculator if you need to. But I know that when x is 18, y should be 130. So what is 6 times 18? That's 60 plus 48, which is 108. To get to 130, I need a 22 here. I'm going to double check that because I did it mentally. If I plug in 23, now 6 times 23 is 120 plus 18, which is 138 plus 22 gives me 160. So I know now that I have the right equation. Then it says we're translating this down by 5 units. Well, this is my y-intercept, right? So if we're going down by 5 units, we're bringing the y down, we're minusing 5, right? So that y-intercept, we don't want it to be 22. We want it to be 22 minus 5, which is 17. So now we have an equation, right, for line K. This is line K. So then now we want to find the x-intercept of line K. Well, at the x-intercept, y is 0, okay? So now we have this really nice equation that we can solve for x. So we're going to minus 17 from both sides. That equals 6x, divide by 6, and we have negative 17 over 6, which is d, boom, done, okay? So hopefully you got a lot of information. What did I do right? I took the grid, I converted it into a linear equation in slope-intercept form, then I applied that translation. Now, if you're unsure if that translation is legit, we can always go into Desmos, right? Just as another way to check this. What was it? We had y equals 6x plus 22. So there's my equation, and it's like, what did I do? I subtracted 5. Did that work? It looks like it did, right? It dropped it down appropriately, translated down by 5 units, just what's described in the problem. So you can use Desmos a lot of times, just if you're a little tiny bit unsure, just to verify what you're doing. Okay. Now we have linear relationship word problems. Okay. A teacher's creating an assignment worth 70 points. The assignment will consist of questions worth 1 and 3 points. Which equation represents a situation where x represents the number of 1-point questions, y 3-point questions? Okay. So we need a total of 70 points, and this is a lot of times what I do. I'm going to construct my own equation from scratch and then compare. So I have x questions, and each one of those are going to be 1 point. So if I get 2 right, I get 2 points. 3 right, I get 3 points. So just x makes sense, right? If I get 3 of those questions and I get them right, I should get 3 points. So plug in. What about y is the number of 3-point questions? Well, if I have 2 questions, I should get 6 points. 3 questions, I should get 9. So the number of y questions I get right, I should multiply it by 3. And here's my equation. Now I'm going to look back at the choices. Check it out. D is the winner. Done. All right. I see Cole popping some answers in the mix as we go along. I love that. You guys are welcome to do that as well. All right. Now this is graphs of linear equations and functions. The graph shows a relationship between number of shares, stock, company Company A, X, and the number of shares from company B, Y. Okay, so we have B and A, all right? Which equation could represent this relationship? So we're just trying to get an equation here. Now, we've got 2 of them in slope-intercept form, 2 of them in standard form. I am going to try, what should I try here? I'm going to try slope-intercept form. I think that's usually the go-to for most people. So we know we have a y-intercept of 40, okay? So we got that. And then we need to now calculate the slope. So we say that we go down 40 to the right by 60. So that's down by 40 to the right by 60, rise over run. That's negative 4 over 6 or negative 2/3. And there's my equation in slope-intercept form. I don't see that option, okay? So that's not there. Can we take this and put it into standard form and then find the right answer? Absolutely. But another nifty way to do this is as follows. For both of these, I see a standard form of 480. Okay. Now I can take my y-intercept. Actually, you know what? This might be. Is this the best way to show you guys? I'm trying to like do the reverse of the y-intercepts and the x-intercepts, if that makes sense, back into the standard form, because usually standard form is ax plus by, right? And when you zero out y, you're plugging in the x-intercept for x, and you should get 480. So this can kind of tell you what your coefficient a is. I hope this makes sense. So for example, I see my x-intercept down here is 60, right? So what times 60 is 480? That's 8. So I know it should be 8x. And then my y-intercept is 40. So what times 40 is 480? That's 12. And so now I've got my standard form of my equation, and that's what they were looking for. 8x plus 12y equals 480. Now, the way you can also do this if we started in slope-intercept form, again, I'm going to give you a couple different options and looks on these problems, as many as I can, okay, just to give you a variety of plans. So again, to convert the slope-intercept to standard, we're going to move the x to the other side. So we got 2/3 x plus y equals 40, and then we don't like a fraction here, right? So what I'm going to do is I'm going to multiply everything by that denominator. So 3 times this first thing gives me 2x. Let me zoom in a little bit here. Oh, Cole, you said it's a little hard to see some of the questions. I got you. All right, let me. Hopefully that's better. So multiply this by 3, we get 2x. Multiply that by 3, we get 3y. Multiply the 40 by 3, and we get 120. So now we have a nice standard form. It just doesn't happen to be showing up here, but at least we can see, oh, this is the same thing. All I have to do is multiply this equation by 4, and I get b. So hopefully that makes sense. All right. Let's move it on to this one, solving systems of linear equations. So linear equations, we're getting a system of linear, usually 2 on the SAT. What is the value of x? So of course we have the option of just putting this into Desmos and looking for the intersection. So I'm going to show you that as well. We also have an option of substitution, which I think is faster here, because I see that y is equal to negative 3x. So we're going to plug and chug. 4x plus negative 3x is equal to 15. 4x plus negative 3x is x. And we've got our answer. Just so you can see in Desmos, we've got y equals negative 3x. Oops, sorry. And then we've got 4x plus y equals 15. And now we look for the intersection point. Might have to scroll down a little bit, but there it is. It's right there. It's not, the point's not showing, but if I zoom out, it should show. Hold on. If I go like this. There it is. There's the point. So you can see my x value is 15. My y value is negative 45. That's how you do it. Okay. Moving along. Here we go. Systems of linear equation word problem. So again, we have a system, and now we got a little word problem talking about everything. This is a hard one, by the way. In the pair of given equations, a and b are constants. The graph of this pair of equations is a pair of the graph of this pair of equations is a pair. So these lines are perpendicular is what they're saying. Which of the following pairs of equations also represents a pair of perpendicular lines? Oh, very interesting. Okay. So we can figure out what A and B are, or like relative to each other. I don't even think I've ever done this problem. This is pretty crazy. All right. So anyways, these are perpendicular. So for the first one, I can figure out what the slope is. So it's 7y equals negative 5x plus 1. I'm putting in a slope-intercept form, divide by 7, and we get negative 5/7 x plus 1 over 7. So this is perpendicular to this line. So I'll put this into slope-intercept form. So check it out. We have by equals negative ax plus 1 divided by by equals negative a over bx plus 1 over b. But here's the key, right? Negative a over b should be the opposite reciprocal of negative 5/7. That's how we have perpendicular slopes, right? So negative a over b is equal to the opposite reciprocal, which is 7 over 5, okay? So now we have a nice little relationship here. We can do a little cross multiplication. We can say 7b equals negative 5a, and then we can say b equals negative 5 over 7a. All right, so now we have an equivalency between b and a, and this can help figuring out these ones, okay? Figuring out which one of these is going to be perpendicular. Actually, wait, I think now I'm going to use Desmos. All right, check this out. So I know that b equals negative 5/7 of a. I can choose arbitrary values. Okay, watch this. This is going to be the most efficient way. These are all 10x plus 7y equals 1. Okay, let's see if we can get this. There's another way to do this by hand, but why not do it this way? 10x plus 7y equals 1. And then for a and b, let's say a is 7, and then b would be negative 5. So a is 7, b is negative 5. Okay, and then now we're going to go through these options. So first we have ax minus 2by equals 1. Okay, so here's my first equation. That's definitely not perpendicular. Then we go ax plus 2by equals 1. Let's try that one. That looks perpendicular. That was pretty cool, actually. So it's probably this one is the answer, but we're going to verify in a second. So we're going to go with this one. And then the last one is 2ax plus by equals 1. 2ax plus by. That's definitely not perpendicular. And then what's the last one? 5x minus 7y equals 1. And then we've got ax plus by equals 1. Those are definitely not perpendicular. All right, so now we're pretty sure it's B. Now I'm just going to show you how you can verify this, right? So let's look at B. If we isolate B, I'm just going to do it quickly. I'm not going to go through all the steps. So if we isolate B, it's y is equal to negative 10 sevenths. Oops. Negative 10 sevenths x. That's moving the negative 10 over, or, subtracting 10x from both sides, dividing by 7. I don't care about the y-intercept. And then if A and B, what did I choose for A and B again? I chose 7 and negative 5. So then this would be 7x minus 10y equals 1, right? As we plug those in. And then again, I'm going to minus 7x divide by negative 10. So we're going to get y equals 7/10 x positive. Again, opposite reciprocal slopes, which means they are indeed perpendicular. Whew, that's a tough one. Hope that made sense, guys. Who chose C? We have, I'm not sure if you meant, I'm not sure, Wei Ming, if you meant this question or the previous question. The previous one was C, so maybe you meant that one. All right. Now moving on to linear inequality word problems. This is a really good one as well. So we have the point x53 is a solution to the system of inequalities, which of the following could be the value of x. Now, me personally, I can see that y has to be greater than 14. And they're saying 53 is the value of y. All I'm going to do is I'm going to plug it into the second equation. Because this one is just telling us, hey, y has to be greater than 14. Well, here it's saying it's 53. So it satisfies the first equation. I don't have to worry about that. Then I got 4x plus 53 is less than 18. Now I got an inequality. I'm going to isolate for x. 4x is less than 18 minus 53. What is that? Negative 35, right? Negative 35 divided by 4. And we've got x is less than negative, I think that's 8.75, right? You can, again, use a calculator. So the only value that's less than negative 8.75 is this one. Now, again, we could graph this, and then we could look at the different coordinates at y equals 53 and see what's a viable x. Actually, I'm going to show you that right now. Let me show you what that looks like in the graph. Y is greater than 14, and we've got 4x plus y is less than 18. And if we look at this, right? Here's the shaded region. This is the solution set. Now we have y is equal to 53. So I'm just going to put that line in. So what are viable options of x, right? The only one that's in this solution set is going to be negative 9. The rest of them, which were negative 5, 5, and 9, those are not in the double shaded region. And the double shaded is the solution set when it's a system of inequalities. All right. There we go. Moving on to 22. If a new graph of 3 linear equations is created using the system equation shown in the equation, blah, blah, blah. All right. How many solutions will the resulting system have? Now, when you have a triple system, right? And by the way, just again for the category, this is graphs of linear systems. So this is a nice graph here, and they've given the 2 equations, but then they're having a third one in here, right? X plus 4y equals negative 16. So we need to see what that's going to look like on this graph. Okay, I can graph it very quickly, right? I know that when x is 0, y will be negative 4. Bop, that's 1 point. I know when y is 0, x will be negative 16. Oh, that's off the graph, darn it. Okay, let's find an easier way to graph this. So then if I have 4y equals, I'm going to put it in the slope-intercept form, negative x minus 16 divided by 4, y equals negative 1/4 x minus 4. So we still have that y-intercept that's correct in the slope of negative 1/4, meaning we go, here, let's do it like this. We go down 1/4 like this. Okay, so there's that other line, and we're going to put our little arrows there. All right, so it says, how many solutions will it have? Well, when I look at these 2 lines, they only intersect at 1 point. But what is a solution for a triple system? This is a rare question. They don't ask these too often. Is it still, do we still have one solution? No. Because when we have a system of 3 equations, all 3 have to intersect. But I can already tell these 2 will never intersect. And so so if those 2 will never intersect, there's definitely no point where all 3 will intersect, meaning there are 0 solutions to this system. Okay. What does it say? Oh, someone says 9 more points. Yes. All right, here we go. Not sure what you guys are talking about, but welcome, Osama. Here we go, number 15. Now we're into problem solving, data analysis. So we finished algebra of the first main category of 4 categories. Now we're on to problem solving and data analysis, ratios, rates, and proportions. This is a very big category. So the proposal for a new library was included on an election ballot. A radio show stated that 3 times as many people voted in favor as against it. Immediately, what am I doing? I'm going to make some sort of a ratio or proportion or a variable expression. I'm going to go variable expression to express this. So it says 3 times as many people voted for the proposal or in favor than against it. So 1x against, 3x for. A social media post reported that 15,000 more people voted in favor of the proposal than against it. So that means 3x minus x, meaning 2x is equal to 15,000. All right. Based on this data, how many people voted against the bill? Just like that. With those relationships, I figured out my answer, because if I know that 2x is equal to 15,000, divide both sides by 2, and I get 7,500. And I get my answer A. Now, I want to verify this, right? So if I know that x is 7,500, and that's the amount that voted against, I know the amount they voted for is 3 times that, which mentally I'll just do 22,500. You can, of course, use Desmos if you want. Now, does this fit the bill? Is 4 3 times against? Yes, it is. Is the difference of these two, the amount that voted for 4 versus against, is it a difference of 15,000? It is. So we've got all these methods of verification. We see that we're pretty comfortable with this answer. That's how you do it. Boom, done. All right. Subcategory 2. This is unit conversion, okay? Now, a lot of times they're going to give you the equivalency for the units, and then it's just your job to utilize those equivalencies and evaluate. So here it says 5.5 yards equals 1 rod. What is 77 rods? So when you have an equivalency like this, what you can do is multiply both sides of the equation by 77, because this is an equation that's allowed, right? So 77 rods then equals 5.5 times 77. I'm not going to do it mentally. I'm going to do it here in Desmos. 5.5 times 77, which is 423.5. 423.5 for the win. That's how you do it. Done. All right, guys. Next, we're going to go. Oops. Now I'm going to go down a level. Here we go. Now we're on to the next category, percentages. Okay, so when I'm seeing a percentage like this, I immediately, and this is a general strategy, I want to turn this into an equation. All right. So we've got 210. What does is mean? Is almost always universally equal. 22 is p% greater than 30. Okay, how am I going to turn that into an equation? P%, so p over 100, greater than 30. So times 30 plus 30. That's one way to think about it. Another way to think about this as a nicer, more succinct equation, p% greater, it's 1, well, actually, this is not more succinct, actually, but 1 plus that p% times 30. That's p% greater than 30, or 30% more than whatever. I mean, p% more than 30. Okay. So now it says, what is the value of p? Well, we got an equation. All we got to do is solve. So I'm going to start by dividing both sides by 30. And 210 divided by 30 is 7. 7 equals 1 plus p over 100. We are going to minus 1. We got 6 equals p over 100. Multiply both sides by 100. And p equals 600. So 210 is 600% greater than 30. Well, what's 600% of 30? 180. 180 plus 30 is 210. It makes sense. So 600 is the winner. And you don't need a percent symbol. Okay. Next is center spread and shape of distribution. Okay. This is asking about mean, but they could also ask about median. They could also ask about mode. So here they're asking about mean. Which statement correctly compares the mean of these two? Now, this is a great one for Desmos if you're not sure how to proceed, right? There's a really awesome function, literally mean. You can say mean, and then you start, oops, with the N, sorry. And then you start typing in the values, and you can calculate the mean, right? You can say 5, 9, 9, 13. So watch this. 5, 9, 9, 13. Okay? And we give it a nice mean of 9. Great. And then I could do the same thing here with these values. But this is one of those beautiful times where the College Board is giving you what's called a layup, right? If you just take a minute and see, hey, this is the same, this is the same. Wait a minute, data set Y is the same, except it has an additional value, and it's a big value. It's bigger than any other value. That tells me right off the bat, because this is mean as an average, data set Y has to be bigger, right? If the fifth additional value that was different was like 3 and the 27 wasn't there, then the mean of y would be smaller than x. But because it's bigger, I know that mean of data set x is less than y, or vice versa, y is greater than x. B is the winner. Done. Next, we get to data representations. All right, let me zoom out a little bit so you can see that top there. Okay. The line of the graph shows the estimated number of chipmunks in a state park. So we are just going to, this is a representation of the number of chipmunks in the park, and it's just saying which was the estimated number of chipmunks the greatest in what year. Just reading the graph. We don't have to say the amount, but we see there it spikes there at 1994. B is the winner. That's it. Just got to be able to read a graph, break it down. Look at this, estimated number of chipmunks, year. Get your head around that graph, make sure you understand it, and then your interpretation is not too bad. Next, we're on to scatterplots. Scatterplots, these are all real data points, right? That's what they're graphing. Usually we're trying to find a linear model or a line of best fit, okay? So I'm going to show you how I'm going to jump through this one. First of all, if we approximate it with a line like this, what's the first thing I notice? My y-intercept is around 10, positive. Well, this is a negative 10 y-intercept. Goodbye. And then what else do I notice? My slope is negative. This is a positive slope. Just like that, I figured out that it's B. What we can also do, if you're not sure how to take those steps, you can plug these into Desmos and just see which one resembles your theoretical line of best fit here. But I think that's a really fast and efficient way to do it. That's how I would do it. Boom, done. All right, now we're moving on to linear and exponential growth. Okay, so often they're going to give you a table like this, and they're going to give you different values, and they're going to say, hey, is this, increasing, decreasing, and is it increasing linear or exponential? All right. So I see it going up by the same amount every time. 1, 1, 1, right? So it definitely seems to be increasing, but you can't just look at the y values. You have to also say, well, is the f of x going up as the x is going up? Yes, these are also going up by 1, 1, 1. So it's definitely increasing, right? If these were going down and this was going up, then it'd be decreasing. Okay. Now the question is it going up in a linear fashion or exponentially? Well, every time the x goes up by 1, the y goes up by 1. So that proportion is the same. Now, if it was different, if every time this was going up by 3 and that was still going up by 1, that's still linear. It's still a constant rate of change, okay? The rate of change of the y's is constant relative to the rate of change of the x's. Exponential would be something like this. This would go up by 1, then 2, then 3. It'd be like growing, right? So that would be exponential, but it's not. So this is increasing linear. That's how you make the assessment. Done. Next, we're into probability and relative frequency. Let me know if you guys can't read any of this. I'm trying to keep it as zoomed in as possible by still showing the title here. Okay, so now we're into probability. Probability is the amount of ways to win over the total possibilities, right? Total number of possibilities in general. For a particular machine that produces beads, 29 out of every 100 has a defect. So this is the proportion or the probability of getting a defective bead. A bead produced by the machine will be selected at random. What's the probability of selecting a bead that has a defect? I just answered that, right? 29 out of 100, C is the winner. Done. And that's, in this case, winning is actually getting a defect because they're saying, what's the probability of getting a defect? Okay. Now we're on to data inferences. I mean, this is also kind of like data interpretation, but usually I had trouble finding like a really good data inference. Like you're looking at the data and what does it infer? This is pretty straightforward, so I don't know if it exactly qualifies. But again, we're reading data, we're reading a graph, understanding that we're in, percent of cars for sale, and this is model year. For what model year we're finding the X value is the percent of cars for sale, the smallest percent of cars for sale, smallest value, meaning lowest down vertically. And that year is 2014. C is the winner. All right, now we're into evaluating statistical claims. Okay, let's check this out. To estimate the proportion of a population that has a certain characteristic, a random sample was selected from the population. And it's estimated the proportion of population has a characteristic is 0.49. Margin of error. Okay, what do we do with the margin of error immediately? We immediately add it and subtract it to this value, giving us an upper bound and a lower bound. The upper bound, that plus 0.04 is 0.53. Minus that is 0.45, okay? This is very important because usually when we're talking about margin of error, we're going to see this range appear somewhere in the right answer. And the only place I see it is in the first option. But anyways, let's keep reading. Based on this estimate, which of the following is the most appropriate conclusion? It is that, and in general, with margin of error, we should see something like language plausible between these two values. And it says right here, it is plausible that the proportion, which we estimate to be 0.49, is between 0.45 and 0.53. That's it. So those are the general steps for margin of error. Pretty much you're not going to see much variation other than that. So if you follow those steps, you should be good to go. Okay. Next, factoring quadratic and polynomial expressions. Notice we are now in the advanced math section. So this is category 3. Which expression is equivalent to this? What are they really doing here? This is factoring out the GCF, okay? So what is the GCF? First of all, is there a constant or coefficient GCF? No, there's no common factor of 5, 6, and 8. So we shouldn't see a number in front. So that means C and D are disqualified. But what's the largest of the variables? Well, x cubed, right? When we're talking about exponents, it's the greatest exponent. The smallest exponent. That's the greatest common factor. They all have an x cubed within them. So I should see x cubed in the front, which is B. Now, just to verify, if I'm pulling an x cubed out, it's basically like dividing all of these by x cubed. X to the 5th divided by x cubed is x squared. That one is just going to be x, and then we should just have a lonely 8 at the end, which matches up with this exactly. That's how you do it. Done. All right, now we got radical and rational exponents. What you need to be able to do very efficiently for these problems is convert back and forth between exponential form and radical form. So I'm going to leave that in exponential form, but I could change that if I wanted to, but it's going to be nicer, I think, and easier this way. Usually we want to go in this direction. Now this is an index and a power. Expressed as a rational exponent, we have power 7 over index. Now this is really great, because what you'll notice is we have the same bases. If we didn't, we might have to modify these bases, right? Sometimes they would be an 8 and they'd be a 4. We'd say this is 2 to the 3rd, this is 2 to the 2nd. You can get the same base that way. But here we don't have to do that. This is pretty nice. We have the same bases. When the bases are equal, we just have to line up these exponents. So we have 8c must be equal to 7/3. We're going to divide both sides by 8. C equals, dividing by 8 is the same as multiplying by 1/8. 1/8 times 7/3 is like 8 times 3 on the bottom, which is 24, which means the value of C is 7 over 24. Boom, done. Now, we can verify this in Desmos if you'd like. I'm going to put it in the exponential form like this with the rational exponent, just because it's a little bit quicker. But check this out. We've got 4 to the 8C, and we're going to add a slider. And then we've got, what was it on the other side? 4 to the 7 over 3, right? 4 to the 7 over 3. Okay, so we have this crazy 25 point whatever, right? And now we're going to plug in our answer. What do we get? 7 over 24. Let's see. If I change C to 7 over 24, I should get this answer up here. So let's try it. 7 over 24, and look at that. They do match up, so you can see that we got the winner. Now, if you just put in a slider and tried to slide it, you can see how it would be quite difficult to get this exact fraction. You could probably get close, but you gotta know how to convert back and forth. Let me see here. Silence. Will you ever go over the questions that cover constants? Find constants, CK, etc. Oh, definitely. Look, listen, next week is whatever you guys want. So if you have a question like that you want me to cover, submit it. And you can post it on the school platform. I'm going to show you guys where to post it later this week, and then we'll start collecting questions. But yeah, I can do whatever you guys want next time. Okay. Now we're into operations with polynomials. Sometimes you'll multiply, sometimes you'll add. This is just a straight addition question, okay? Now, can we add these together? That's the first question. And the answer is we cannot, because the exponents are different for the x's. The y's are the same, but the x's, they're different, which means they are not like terms. So we cannot actually add these together. But what did they do instead? They factored. They factored out a GCF. Of the coefficients, the GCF is 6. So we should see a 6 in front, which we do for all of them. For the 8, it's the lesser of the two, which is x squared. I should see an x squared in front, which I do for all of them. For the y's, they're the same. So I should see a y squared in the front as we factor this out, which I do for all of them. All right. Well, that doesn't help too much. All right. So then we got 6x squared, y squared for the GCF. And then when I pull that out of this, what should I have left? Well, I'm pulling the full 6 out and the y squared out. But x squared out from x to the 8th, we should have x to the 6th left, plus something else. So now I already know it's got to be C. But then what should I have left in here? Well, I'm pulling out a 6, dividing 12 by 6. That should be a 2, pulling out the full x squared and the full y squared. Nothing else should be in there, which means that we have verified C is the winner. Done. This is kind of a factoring question, I'm just realizing, but you might also have operations with polynomials where you're going to be multiplying polynomials. So make sure you check my critical concept videos on advanced math to go over how to multiply polynomial expressions. Okay, now we're talking about expressions with operations with rational expressions. Rational expressions is just something over something. And operations could be addition, subtraction, multiplication, division. So I chose one with addition, which I think is the hardest. Okay, so what are they saying here? Which expression is equivalent? We're trying to consolidate these two into a single term. That's really what we're talking about, which also means we're trying to get common denominators, right? So that's what we're trying to do here. I'm also going to show you how you can do this in Desmos as well. When we talk about equivalent expressions, you can basically put in this top one and it'll give you a graph. And then you can put in all four of these and see which one matches up. Now, obviously, this will take you a while. So it's not my favorite option because there's so much to type out. But you can do it that way. All right, I'm going to go the straight up algebraic route instead. Now, usually you're going to want to factor in some way, right? And not that you have to, but it's going to make it a lot easier. So I'm going to try and factor the denominator here. So I see that there's a GCF of x and y in the bottom there. So I can factor out x, y, and then I've got a single x left inside. And then, oh, look at that. That actually comes out. Well, that's interesting. Because I could cancel this, but I'm not going to. I'm not going to because that's going to make it, we're going to have to put it back in anyways to get common denominators. But it is going to make it easier to get a common denominator here because this one is now this. So to get a common denominator, since I already have an x minus 8 here, I just multiply by xy and xy, right? So that gives us our common denominators. So now we have xy times y plus 12 on the top over that same denominator. I won't write it out actually. All right, now we're going to distribute, and then since these are being added, we're going to add these numerators together. So this one, or actually, let's do the bottom one first. So we have xy squared plus 12xy, and then that one is going to be y times x is going to be plus xy, and then minus 8y. So 12xy plus xy is 13xy, so we should get xy squared plus 13xy minus 8y. This should be on the numerator. And I see it here and here, which means these two are out. And then what is the right denominator? Well, I already know that this is my common denominator. So if I redistribute it, it's not D. That doesn't make sense. But if I redistribute it, I get x squared y minus 8xy, which is C for the win. Boom, done. Let me see if there's any questions. I did not do tests in order, LOL 14. Oh. Did you do number 5? People said that was close to the test, but I got a 1540 and it was easier than test 4. Yeah, I've done test 5 on the channel. I posted it in the calendar so you guys can see me do it as well. I didn't think it was, you're saying people said it was easy? I thought test 5 was hard on the math, personally. That's my recollection, but I don't know if you guys feel differently. Hey, more power to you. Okay, now we are into nonlinear functions, right? This is a polynomial function. It says which table of values represents y equals f of x minus 3. Now, where you can get tripped up here is if you don't notice this and you kind of read ahead and you're like, oh, which is the right function, which is the right table of values for this function, without realizing that you're supposed to minus 3 at the end, right? F of x minus 3. That's a pitfall. Anyways, now that we have this correctly laid out, we can now check these different tables. So if I plug in -6, that's going to zero out this first expression, which is going to zero everything out. So -6 should give me -3, which is not A, immediately gone. This is correct. This is correct. This is +3. Immediately, right off the bat, I eliminated 2 choices. Beautiful. Next, what do they have? They both have -5. So -5 should again give me -3 because it's going to zero out. And the only one that gives it to me is B. So I know B is the answer. And then 4 is going to zero it out, which should again give me -3. All right. Now, if you're like, well, wait a minute. I don't know if I would have thought of that. How would I do this in Desmos? Okay, let's get f of x in here. Now, watch, I'm not even going to do anything fancy. I'm going to say x plus 6, x plus 5, x minus 4. Watch this. F of x equals x plus 6, x plus 5, x minus 4. All right, I just have to make sure I didn't type in anything wrong. Yeah. And then next, I want f of x minus 3. So my blue function is the transformed function. So I didn't even have to know how it kind of comes together in this equation, anything like that. All I know is I got a correct equation here. Then I can go back and I say like, all right, I know they're all looking for x equals -6, x equals -5, whatever. Watch this. X equals -6, x equals -5. What are the corresponding y values for both of those lines? Well, for the green line at -6, I get -3. For the purple line, I again get -3. Oh, that just confirms that it has to be B, right? We have -3 for both -6, -5. That's how you do it. Boom, done. All right. We are almost at that or we're probably past the halfway point. I'm going to pause on this one, guys, and I'm going to let you guys give it your best shot. So let's pause. Throw your answers in the chat. Let me see what you got. Take it away. Yeah, the last question was just shifting down, Cole. Good question. Yeah, because of the -3 or 5 or whatever, I think it was -3. That's a vertical translation down, which I did cover in this in these slides. You know, when you have f of x minus something, that's a translation down. Good question. By the way, as you guys are working this problem out, if you could click that like button if you haven't done so yet, that'd be huge for the channel, just saying. Had the chat delay, solved it pretty fast. Oh, Cole's got C. We got Georgie. Georgie, welcome. I haven't seen you before in the chat. Thank you for participating. Khan also has C. This is great news. A lot of people are seeming to get the same answer. I don't even know what the answer is yet, by the way. I haven't done it yet. So I have no idea if you guys are correct. Keep going. Post your answers. Don't be shy. Don't be afraid to get it wrong. Getting stuff wrong is part of the process. Actually, I worked with a few kids today for SAT math and for my one-on-ones. And that's what I was telling them. You know, when you make these mistakes, it's actually a beautiful thing because that's your opportunity to learn and grow. And it's also like when you make a mistake, as opposed to just like kind of getting something right with a guess, you're way more likely to remember the proper process and the critical concepts behind that question in the future. I think that's what I found anyways. June SAT. JDW posted video. June SAT math problems. Cheerio. That if those are actually from the June SAT, we're not allowed to know what they are. We're not allowed to even look at them. That may have been. God, I don't know. I mean, look, I don't want to make any accusations. I have no idea what's going on. Maybe the College Board released them, and I was not aware of that. So I don't want to say too much, but I would be very cautious in looking at stuff like that. Because if you're saying it's from the June SAT, I'm like 99% sure the College Board has not released the June SAT. Okay, so we got a lot of C's. So let's see what it is. All right. So basically, what are they doing? They're isolating x. Immediately, I'm going to start. I don't like this purport. Oh, no. You know what? I'm going to start by multiplying both sides by y. Okay. So then we get y over 7b equals 11x. And then last but not least, divide by 11, which is the same as multiplying by 1/11. Goodbye, 11. And we get x equals y over 77b, which is C. You guys all got it right. What legends? What legends? All right, Cheerio, don't worry. You didn't do anything. You didn't post it, so it's all good. I'm just giving you a heads up. All right, now we're on to solving quadratic equations. What is one of the solutions to the given equation? Now, there's lots of ways you can do this. Obviously, you can throw it in decimals just like this. Just replace the, actually, you could do it with z, but replace the z with x just to be safe. And you get your answers. But I'm so old school, I go straight into factoring mode, right? And I'll just write x. Who cares about z? It doesn't matter. What two numbers multiply -24 add to +10? That would be +12 and -2. There's my factored form. So my two solutions are whatever zeroed these out, -12, +2. You could answer either of these. I'll just go with the positive version 2 for the win, boom, done. One of the solutions, right? And again, you can have negative answers for your response questions for the digital SAT. You couldn't before, but now you can. All right, number 25. We got in the xy plane, the graph of the equation, boom, intersects the line at y equals c. So this is linear and quadratic systems. We're talking about a horizontal line and a quadratic like this, but they're saying they intersect at exactly 1 point. All right. So what is the value of c? Now, when we're talking about 1 point, we're talking about the nature of solutions, one solution, which means that we might want to think about our discriminant. So they're saying y equals c and this are intersecting at 1 point. So let's do a little substitution, right? That's usually the play for systems of any kind. So we'll say c equals negative x squared plus 9x minus 100. Now to get the discriminant, we're going to set everything equal to 0. So I'm going to minus c from both sides. Oops, hold on. Make this a little thinner. And we got negative x squared plus 9x minus 100 minus c. Now, discriminant when we have one solution is equal to 0. So what's my discriminant? B squared, that's b, which is 81, minus 4. A is negative 1. It's that coefficient from the x squared. And then c. Now, here's the tricky part. You might say, oh, it's just negative 100. Wrong. C, the actual c is also a constant. So it's negative 100 minus c. It's that full value. And now we got a beautiful equation. Now let's solve. Negative 4 times negative 1 is just 4. So we got 81 plus 4, and then we're going to distribute that 4 like so. So we got 81, 4 times negative 100 is negative 400. 4 times negative c is negative 4c. You might say, what about distributing the negative? Remember, it turned into a positive, so nothing to distribute. Equal to 0. Let me scroll down. Then we're going to combine these guys. That is negative 319 minus 4c equals 0. Add 319, negative 4c equals 319. Divide by negative 4, and we got negative 319 over 4, which is c. Again, we could do this in Desmos as follows, or at least verify in Desmos. Check this out. Y equals negative x squared plus 9x minus 100, plus 9x minus 100. And then we've got y equals c. Now, I could have also done this, right? I could have looked at the equations. Oh, no. I hate when it does that. Sorry. This is the thing that's weird about Desmos. When you set y equal to c, it like treats c as x for some reason. So I don't know how. Okay, hold on. To add a slider. You know what we'd have to do is we'd have to go like, yeah, we can't say c. We're just going to have to plug in the values. So we've got our different options, right? We've got negative 481 over 4. It's not that big deal, but all right. Nope, that's two solutions. Wrong. We've got negative 100. Nope, that's two intersection points again. That's wrong. And let's just try ours, negative 319 over 4. And look at that. We got that nice, perfect single intersection point, meaning one solution. That's how you verify. Boom, done. Okay. Number 7, what is the positive solution to the given equation? Radical, rational, and absolute value equations. Now, this is a rational equation. Again, rational meaning expression over an expression. Fraction, essentially. You could also have an absolute value equation, things like that, right? Which we've covered in my critical concept slides. But this is just one of those 3 options. So how would we solve this? You know, a lot of ways, right? We could multiply the denominator over, turn it into a quadratic, set it equal to 0, solve. What about using Desmos? I would say Desmos is great here. So check this out. We got a nice equation. 55 over x plus 6 is equal to x. These two lines are the two solutions. We just got to figure out where they're hitting the x-axis. One is hitting it at 5. The other one is at negative 11. So those are my two solutions. If that confuses you, you can also just separate them out into two functions and look at the intersection points and the x values. Again, negative 11, positive 5, same thing. And it says the positive solution, which is 5, boom, done. And then you can plug it in mentally and check. 5 plus 6 is 11. 55 divided by 11 is 5, which works there, boom, done. All right. Now we're on to quadratic and exponential word problems, okay? This is, of course, looks exponential based on the answer choices. The number of squirrels in a population was 150% more than the number of squirrels in the population at the end of the previous year. Okay, 150% more. So if we think about exponential equations, That's the amount we are increasing by, right? We're going up by 150%, which means we'd have 1 plus 1.5. 1.5 is 150%, right? So I already know that when we add these together, what I should be seeing in my parentheses is a 2.5, not a 1.5. Then it also says that, hold on, model estimate to the end of 2016, there were 180 squirrels. Okay, I should see my initial value, meaning since it's starting at 2015 when t is equal to 0, because t is years after 2015, I should see my initial value in the front. You might think 180, but 180 is 2016. Incorrect. So they can't be the value in 2015. So it's got to be B. How do I verify this though now? Okay, so they're saying the initial value when t is 0 is 72. Well, then when t is 1, we should be increasing by 150%. What's 150% of 72? Let's see. 150, that's 108, okay? But it says it's increasing by that much, so it's not becoming 108. We're not taking 150% of 72. It's increasing by that amount. So we add 108 to 72, and we get 180. And there we go. We have now verified that B is, in fact, our winning answer. It matches up with what this is describing. Boom, done. All right. Here we go. Oh, Matthias, well done. Well done. You nailed it. All right. Now we're into quadratic graphs. What is the x-intercept of the graph? Right, a quadratic graph is a parabola. That's what we see here. X-intercept is where it hits the x-axis. All we got to do is find that x value for that x-intercept. You could clearly see it is 7, okay? This is one example of a quadratic graph. They might have you read the y-intercept, the x-intercept. This x-intercept also happens to be the vertex, FYI, which is either the min or the max, depending on the orientation, right? In this case, the vertex would be a max. But anyways, that's how you do it. Next, we're going on to exponential graphs. What is the y-intercept? Again, it's an exponential graph. Exponential will go like this. That's exponential growth, or like this, exponential decay. But again, feature the graph y-intercept where it hits the y-axis, and that is at 2. But is it 2, 0 or 0, 2? It is at 0, 2 because the y-intercept, the x value is always 0. All right. Last row here. We're almost done, guys. This is amazing. Okay, wait, hold on one second. Let me get it over here. And we are still into polynomial. I'm going to take another break and have you guys answer a question when we get to the final topic. Polynomial and other nonlinear graphs. What is this? This is a rational function, right? Rational function where we have something like this, and there's usually an invisible dividing line, aka an asymptote that they're not going to draw in, but it's probably at -4, okay? Anyways, now let's talk about this. Graph y equals fx is shown on the xy plane. What is the value of f of 0? This is very straightforward. This is a function. Actually, this is function notation, rational function graph hybrid, because you need to know what this means. This means what's the function value when x equals 0? X equals 0 on the y-axis, aka they're asking for the y-intercept, which is 3, which means D is the winner. Done. If you don't mind asking, what is... Oh, people are asking about SAT scores. You don't have to share that, guys. You can keep that confidential if you'd like. All right, 23. This is a really deceptively tough question, okay? I'm going to pause for a second. I want to see your guys' answers and begin. Give you guys about a minute. And by the way, I have not done this problem yet, so I don't even have an answer. I've done it before, though, this one. I just can't remember. Here, I'll start to make a diagram. Okay. I see some answers. I see D coming through. I see another answer, which is B. Okay. Now let's talk about it. I love this question because, again, a lot of people get this wrong. Now, what most people do is I shouldn't say most people. What a lot of people do who get this wrong is they take this value and they multiply it by 1760, which I'm guessing is this value, okay? And I'm going to show you two ways to think about this. So the first way is I'm going to actually make a diagram. I'm going to create something that has 4.36 square miles, which would be something which is by 1 mile by 4.36. We could do it infinite ways. This is just a simple way. Now again, they gave us a conversion for distance, not area. So now I can use the distance to convert these, right? So in yards, this side would be 1760. And then this one, 4.36 times 1760, hold on, would be 7,673.6 yards. Okay, now I have the dimensions yards by yards, and then to get square yards, oh, it's very simple, right? I just take that and multiply by 1760. So then I take this times 1760, and we get this crazy number, 13 million something something, which is D. So that's one way to think about it. The other way to think about it is if there's kind of like a relationship between the side lengths, which is 1 to 1760. For the areas, it's that same relationship, but squared. Okay, so we square both of those. So now you can see that to get the equivalent area in square yards, we have to multiply by 1760 squared. That's the shortcut, but if you're more comfortable with making the diagram, which I am, that's the way that I like to go. All right. We only got 5 questions left, guys. Here we go. This is an angle question, congruence, similarity, and angle relationships. Now, they're usually always going to tell you these are parallel, but make sure that they do. So these two are parallel. And then it says, what is the value of x? So what is the relationship of these two angles? They are same side exterior, which has the same relationship as same side interior, which is that they are supplementary. Supplementary means they add up to 180. So what plus 33 is 180? 147. Now, the beauty of this is, like, if you forget that specific relationship, there's only 2 relationships with parallel lines, equal or sup. It's one of the two. These definitely don't look equal, right? Equal would be alternate interior, alternate exterior, right? Those are equal. So they're not equal. You got to go sup, means they add up to 180. That's how you can get there. Boom, done. All right, next, right triangle trigonometry. So we're talking, and we're not using a trigonometric function here per se, but it is a right triangle. So they say that we have the legs of length, which are the smaller sides, not the hypotenuse, not opposite the 9 degrees. We have 21 and 24. And notice, I like to put the 21 with the side that looks smaller just so this makes more sense. And then it says the hypotenuse is 3 rad D. But we have to figure out what is the hypotenuse. Okay, let's figure that out. Let's call it X. Now, right triangle, I'm going to use Pythagorean's theorem. Okay, 21 squared, A squared, plus B squared, 24 squared, equals X squared. So what is that? Let's use Desmos. 21 squared plus 24 squared, and we get 1,017. But then that's x squared, so x would be the square root of 1,017. Well, wait a minute. I don't see a 3 in front of this. I see 1,017. That means we got to simplify. In order to pull a 3 out, I need to separate. Oh, I'm hoping that 9 is a factor of this, but it's got to be, right? If it's not, then this problem is not possible. So again, let's use Desmos and let's hope that this is the case. 1,017 divided by 9. It is the case. You'd be left with 113. So 9 times 113, they take the square root of 9, right? Pull that out because it's a perfect square, and we got a 3. What's left inside is 113, which means D is 113 for the win. Boom, done, right? You notice how this is a right triangle problem, but it's also a radical hybrid, square root hybrid. Okay. Next, we have circle theorems. We have the circumference, which is all the way around, is 144 pi. And diameters PR and QS. Boom, boom, meaning they go through the center. The length of arc PS, which is right here, is twice the length of PQ. So this is 2x and this is x. What is the length of QR? Well, if I know that this is a diameter, this is half and this is half, right? And I know that these two arcs opposite each other are going to be equal. So that's also x and that's also 2x. Okay. So what does that mean? PQ, therefore, is 2x out of 2x plus x plus x plus 2x, which is 6x, meaning 2 out of 6, or 1/3 of that full circumference. So what's 1/3 of 144? It is 48. 3 times 48, that's 120 plus 24, which is 144. B is the winner. Done. All right, got a few questions left. Here we go. Now this is a straight trig problem. It says JKL, and we're assuming we're talking about trig. We're talking about right triangles. So cosine of K is 24. Oh, sorry. Let's put K up here. Cosine of K is 24 over 51. Cosine is adjacent over hypotenuse, okay? Now, does it actually mean that the side lengths are 24 and 51? No, but they have to be in that ratio. Does it really matter at this point when we're setting up the triangle? No, it's fine. This is good enough just to kind of get a rough idea of a potential triangle that works. And we know that J is our right angle. That means L's got to go down here. So now it's asking, what is the value of cosine of L? That would be adjacent over hypotenuse relative to L. So that means we got to figure out this side before we can get our answer. Okay, so we can use Pythagorean's theorem to do so. 24 squared plus x squared equals 51. So let's see that here. 24 squared, I believe, is 576 from recollection, but let's double check. Oops, hold on. 51 squared is 2,000. Okay, so then we're going to get 2601 minus 576. And that's 2025. That's like 45, right? Square root of 25. Yeah, it's 45. So then I've now figured out that this side here is 45. So cosine of L is adjacent over hypotenuse, 45 over 51. To reduce it, divide top and bottom by 3, and we get 15 over 17 for the win. Boom, done. Yeah, how many more do we? Oh, last one. Last one. Ladies and gentlemen, I'm going to pause for 1 second. Answer this question. Let's see what you got. Do your thing. I see some answers coming in. I gotta say, Cole is very rarely wrong, so he might have ruined the surprise. If you guys have been joining the streams a lot, so he did say 8, which is B. I'll tell you guys, he's right once again. And so, by the way, Fortnite Sweaty Kid also got this right as B. Don't want to steal his thunder or steal Fortnite Sweaty Kid's thunder. So you got it first. Well done. So how did they get there? Remember, the equation of a circle is, this means my center is at 5, 3, right? That's h and k. And on this side is radius squared. So if 16 is radius squared, that means radius is the square root of 16, which is positive 4. But the radius is half the diameter, which means the diameter has to be 8. And there we go, guys. There is our mixed review based on question type. So we did 1 per question type. We got 37 problems in all, and I hope you guys like that. By the way, guys, if you're on and you've been watching the stream and you did like it, please give me a like. We don't have that many likes, and I know we got a lot of, fair amount of people on the stream, so I'd love everybody right now, if you could, to click that like button. Really appreciate it. Okay. Thank you guys so much for joining. This is class 6 and 7. We're almost at the finish line. I'm seeing tremendous stories of growth. This is absolutely unbelievable. I'm so excited. This is the first time I ever did a class like this, and me and Dan are having so much fun with all of you. So thank you guys so much. This is incredible. Get ready for next week. We got so much crazy content coming out. For those of you guys who are watching and subscribed, you guys are going to be way ahead of the competition once all this stuff comes out and you watch everything. Trust me, it's going to be incredible. I'm going to be working day and night to get a ton of videos. I got like 8 videos on my list to get out between now and next Friday. So it's a lot. We're going to see if I can pull it off, but hopefully I can. And that is it. So thank you guys so much for joining. Once again, if you did like this video, make sure to click that like button. And if you want to see more from the channel, make sure to click subscribe. Oh yeah, also, if you want the best test resource for SAT, practice digital SATs, check out SAT Crash Course. The banner's at the top on that side. You can see it over here, right? And you can use the code SCALAR for 20% off. And again, join our school community. You guys probably already are members, but if you're not, I'm posting the link once again. This is so you can be notified of everything we're doing in this last week and a half before the SAT. So there it is. Everything is totally free, and we're having a blast. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.